Hi, I'm Quincas and I'm a synth DIY guy. Welcome to today's video about the Cubusynth engine. The Cubusynth engine is a dual analog VCO with wave shaping functions, internal modulations, and a chaos generator. It's based on the 3340 chip and features 4 waveforms plus a wavefolder per VCO and 4 modulated outputs, all available simultaneously. The Cubusynth engine can work as 2 independent VCOs or as one complex FM oscillator. With its internal chaos engine, it creates semi-random voltages generated by the 2 oscillator cores. This signal is then normalized to the CV input for pulse width modulation and exponential FM. Each of the 2 VCOs offers a switch to select one of the 4 wave shapes to be used by the wavefolders and the linear FM input normalizations. There is pulse width modulation, linear and exponential FM inputs. The 1 volt per octave tracking is stable over up to 10 octaves. The chaos generator has an external clock input. There is a switch to change the emphasis of the chaos generator. There is a chaos offset knob. And there are modulation outputs. One of them is a comparator, which outputs a pulse whenever VCO2 is higher than VCO1. That's the 1 versus 2. There is a simulated ring mod based on an XOR gate. There is an amplitude modulation output where VCO2 is modulated by VCO1. And there is a direct chaos output, so you can use the chaos generated in the module to modulate something external. The build is fairly complex. I do not recommend this for beginners, but the manual has all the information you need. Just make sure you read it carefully. Let's have a look at what comes with the kit. So first thing you notice is a nice printed version of the manual. Do check it out because you'll see I made a big mistake right in the beginning. And yeah, notice how most of the baggies are paper, which is nice and ecological. And let's start pulling out the parts. Resistors, here's the panel. These are probably the PCBs, yep. 2 PCBs, the control PCB and the main circuit PCB. And there's that little switch PCB over there, source of my woes. Anyway, here's some pots, some switches, rotary switches, some capacitors. I like to, as I open the kit, organize all the parts in my little blue mat here. So we have the ICs, the IC sockets. Transistors, try to keep them separated by designation so you don't get them mixed up when it's time to install them. There's a bunch of headers to connect both boards together. Here are all the jacks and their respective nuts. And here's a bunch of LEDs. There are colored LEDs. Some of them are labeled. So keep the label on until it's time to install them. And some nice aluminum knobs as well. The trim pods for calibrating the module. A few more jacks here. Yeah, some of these parts are not for this kit because, as you will see, Ruben also sent me this nice VCA kit. We're gonna have a look at how to build this on a future video. So let's just put it aside for now and let's get started. I've mounted the main board on my helping hands here, and the first thing I'll do is place all of the resistors and diodes. They're the flattest components. And this is a nice factory-made board with plated through holes, which means that you can actually solder from above like I like to do. It just makes things quicker, easier, and cleaner, not having to turn the board around all the time. Once you've soldered all of the terminals, you can turn the board around to trim the excess leads and then touch up your work from behind. Just to make sure everything looks nice and shiny. And now let's do the same with the control PCB. Again, put all the resistors, and if there are any diodes, those in as well. Here's my new iron, by the way. I got this thing from China, from AliExpress, I think. And it's replaced my hobby Weller. Much quicker to warm up, lighter on the hand. I think it's the upgrade to the TS100, that classic iron that a lot of people have been using for hobby electronics. Anyway, let's clip these resistor legs now. Let's touch up a few terminals that didn't get soldered very well. Finish clipping those leads and then touch up the work. Usually just reflowing the solder is enough. Sometimes adding a bit. Now let's assemble the switch. Now this part, I made a mistake. I didn't read the last sentence on the switch assembly part of the manual where it says to clip the excess leads, and I didn't do it. In the end, when I installed the switch, it created shorts with the header underneath. I ended up having to remove it and then clip those leads and put it back in, which was a huge hassle. So yeah, just make sure you do that before you solder the switch onto the board. So now I'm using the board to hold the IC sockets in place as I turn it all around. And now I will solder the opposing corner pins of each IC socket just to keep them nice and steady. And then I can continue and solder all of the remaining terminals for each IC socket. Looking good. Now let's start installing the capacitors. Some are ceramic disc capacitors, which are not polarized. In fact, all of these that I am installing right now are non-polarized ceramic or film capacitors. Some of them are a little bit too wide for the holes in the PCB. So I can use my needle nose pliers to kind of straighten out the legs, bring them closer together so that this can fit where it belongs right there. Open up the legs so it doesn't fall out before you get a chance to solder them on. Now we'll solder all of these in place, trim the leads, touch up the work. Let's do the same to the main board. Okay, now we're moving on to the transistors. Here it's really important that the transistors match the drawing on the silk screen and the designators are correct as well. There are a couple of different kinds of transistors. And in the end, I like to reflow the transistor terminals from behind just to make sure that there are no shorts. There's no solder blobs grabbing two terminals. These are the polystyrene, I don't know how to say this, polystyrene capacitors. These are really fine capacitors, expensive ones, often used for filters. Here I think they are for the timing of the oscillator chips, but I may be wrong. Now let's install the power header as well as the expander header. There's an expander for this and I'll show you how to build it as well on a future video. Now these are electrolytic capacitors. These are polarized and they go on the other side of the board. So make sure you install them on the correct side and with the correct orientation. Clip the leads. And now the trim pots, which also go on the back side of the board. Double check the values and go ahead and solder them up. Once they're soldered on, you can clip those leads. And again touch up the work with iron. Alright, now let's start assembling the headers. And I like to put the headers completely together, both male and female, and attach both boards and then solder them, and this ensures that everything lines up and fits perfectly. Wiggle that control board around until all the header pins go through, and go ahead and solder on both sides. As you can see, with the headers I do the same thing as with the IC sockets. I start with the extremities to keep it all solid so it won't fall apart while I'm soldering, and then I can cheerfully solder all of the remaining terminals without fear of it falling apart. Cool, now I can pull them apart and I know that they'll line up and they'll fit again whenever I need them to fit. Now let's install these switches, the toggle switches. Now my board was a little tight. As you can see, I'm having to kind of twist one of those switches, and that's not ideal because the way this is set up, I might need to pull the boards apart. Let's go on to soldering the switch, the top switch, 4-position switch. And this is where I noticed that my switch was shorting with the header, right? I only noticed after I'd finished soldering it on. So I actually had to remove it. A little later you watch me pull it out and trim those terminals from underneath so they don't short with the headers. But anyway, as you can see, yeah, these switches are too tight on there, so I got a Dremel. You're probably not going to need this. I think only a few of the production boards on DIY kits had this issue. But yeah, definitely do this if your switches are tight, because if you have to troubleshoot this module later, you need to be able to pull this board out without having to unsolder the switches and twist them. That would be a mess. Let's clean it up a little bit of that Dremel mess. And yeah, I got a couple of resistors that were missing from my original kit. Let's install those. Solder them up. We're almost done. And now I'm gonna remove that switch because I noticed that it was shorting with the header, because I didn't do that simple step of just cutting the terminals flush at the bottom of the switch. So I'm using desoldering braid to remove all the solder and eventually be able to pry out the switch. See, now I'm gonna cut it up. See, those terminals from the bottom there, they were touching some of the header pins. And now we can put the switch back where it goes. Alright, so now let's snap on the ICs. It's really important to make sure that they're oriented correctly. Use the manual as a guide. There's a visual representation there, an actual picture. So use that to guide your placement of the chips. And now let's start with all the panel components. The many jacks go on there, as well as the tall trimmers, the rotary switches, and the potentiometers. Now these rotary switches need to have their position lugs cut off, and make sure they're oriented correctly. The numbers should match. The terminals are numbered. Okay, now check the manual to make sure you place the LEDs correctly according to color, right? Now we're going to turn this whole thing around again using the panel fact, we might as well tighten some of the nuts. I think I went overboard and tightened all of the nuts at this point, but you don't need to do that. If you just tighten like 4 nuts on the corners, that should be enough to keep the assembly together, so you can turn it around and solder. Right, so kind of trying to position the LEDs correctly there, so they're touching the panel from behind, and now we can solder everything up. Once you solder everything up, trim the leads, and yeah, we'll see how the module comes together. And I noticed that I need to pull it all apart again because I didn't put the nuts that go on the toggle switches that are coming from the backboard through the control board, right? Once I've done that, and I've also realigned some of the LEDs to make sure that they line up with their windows on the panel, we can now put all the nuts back in and even install all of these nice aluminum knobs. Aluminum knobs. Cool. And this is it. Let's check the power headers for shorts. Let's make sure there's nothing shorting the power lines. I made a video about this procedure. You can search for it. Alright, so let's calibrate this thing. It's pretty easy. First thing we'll do is turn it on, see that it's working, right? And then we'll connect the sine wave from oscillator 1. We'll adjust the sine wave symmetry just to make sure it's centered around 0 volts. So I'm using my data for that. Yeah, you might check out that little VCO cheeky power. It's really handy. Right now it's powering both my data and the Cubusynth engine for this calibration procedure without needing to have a case out. I've also centered the second oscillator's sine wave. You know, everything you do here, you have to do twice for both oscillators. So I'm going to use my KeyStep Pro to send it volt per octave information so that we can tune the octaves. So now we're going to adjust the volt per octave trim pot as we check octaves from the KeyStep Pro while looking at the tuner from data. And basically you just try to get it so that all the octaves match. And in this oscillator, it's not as usual where it's counterintuitive. Usually when you calibrate an oscillator, if the first octave is high, you actually turn the trim pot so it's even higher, because what that's doing is reducing the distance between the octaves. It'll also raise the lower octave, but it'll raise it more than the top octave, right? But this is not the case here. This oscillator is easier to calibrate. It's more intuitive because if you see that the note is high, the octave is high, you just tune it so it starts getting lower, and then check the octave again, the lower octave, adjust it, go back to the top octave, and keep turning that trim pot until both octaves match, and then check octave 3, 4, 5, and when you get to the higher octaves, if it doesn't line up, then you use the high frequency trim. You might not need it. I only needed it for one side, for one of my cores. The other one, once I tuned the volt per octave trim, it was fine throughout its entire range, so I didn't need to use a high frequency trim. But yeah, you'll see it when you get up there, octave 5, 6, 7. If the first 4 or 5 octaves are fine and then the higher ones are not, that's when you would use the high frequency trim. And that's it for calibration for this module. I would have thought it would have had more things, but really it's just the volt per octave and the sine symmetry. Now, this is a good time maybe to mention, there are a few mods that are suggested to improve this module. For example, the amplitude of the wavefolder outputs is a little low compared to the main outputs, and that can be adjusted by swapping resistor values. And the same thing with offset. There's a bit of a positive offset on these wavefolding outputs, which can also be fixed swapping resistor values. I will list those in the video description so that even before you build this module, you might as well, instead of swapping the resistors once they're soldered, go ahead and build it with the correct resistors. Although it does take a little bit of experimentation, you might have to put some in, remove them anyway. But regardless, I'll put that information down there. And yeah, I think this is it for the video. I hope you liked it. I hope you enjoyed watching me build this, and stay tuned now for the soon coming demo video where we'll check out all the amazing sounds that this module can do. It's really a lot of fun. That's it. See you soon and stay noisy.